practical investigation part 2 now, to do with uncertainty in calculations. A, addition and subtraction. When you add two quantities together, what do you do with their uncertainties? When you subtract one quantity from the other, what do you do with their uncertainties? Here are the rules. First one, add. Very important. Add the absolute uncertainties. You never subtract uncertainties, because uncertainties always get bigger and bigger, never smaller and smaller. So that's the first rule. Then round the actual or the absolute, same thing, absolute uncertainty up to 1/6 fig, as mentioned previously. Then you round the quantity or the value, another word for value, up to the same number of decimal places as the uncertainty, as mentioned on previous occasions. Here is the example. We have one quantity L1 equal to 2.4 plus or minus 0.1 centimeters. L2 is equal to 1.7 plus or minus 0.1 centimeters. Calculate A, L1 plus L2, B, L1 minus L2. Answers on next page. Answers: A, L1 plus L2. For the values, you just add them up as per normal. And for the uncertainties, you add them as well. That's the final answer. 1/6 fig for uncertainty and both to 1 dp. Now B, L1 minus L2. For the values, you just do the normal thing. 2.4 minus 1.7. But for the uncertainties, you still add them. And that's the final answer. You can see that both uncertainties are the same because you add in both situations. B, multiplication and division. When you multiply two values together, what do you do with their uncertainties? When you divide one value by the other, what do you do with the uncertainties? The rules here says, firstly, convert all the absolute uncertainties to percentage uncertainties. And then you add percentage uncertainties. Here is a difference. You don't add absolute uncertainties for multiplication and division. And then you convert the final percentage uncertainty back to the absolute or actual uncertainty. Then you round the absolute uncertainty to 1/6 fig, as always. Then you round the quantity or the value, same thing, to the same number of dp as the uncertainty. The example here we've got L1 is equal to that, L2 equal to that. Then to calculate A, L1 times L2, B, L1 divided by L2. You can see the answers on the next page. Answers for A: calculate, first of all, the percentage uncertainty of L1 by dividing the absolute uncertainty by its value times 100, and you get 2.1%. It can be to 2 or 3 sig figs. Then you calculate the percentage uncertainty of L2 by dividing its absolute uncertainty by its value times 100, and that comes to 6.3%, 2 sig figs. Then you multiply L1 by L2, which is equal to 4.8 times 1.6. You just multiply the values together as per normal. And then for uncertainties, you add the percentage uncertainties. You don't multiply. And the value comes to that. The percentage uncertainty comes to that, 8.4%. Then you have to convert the percentage uncertainty back to absolute uncertainty. So you work out 8.4% of 7.68, and it comes to that. Then you have to round this off to 1 sig fig, so it's 0.6. And then you had to round off the value to 1 dp, because this is to 1 dp. So the final answer is 7.7 plus or minus 0.6. Answers for B. The percentage uncertainties of L1 and L2 are still the same as previously calculated in A. Now you divide L1 by L2. For values, you just divide as per normal. But for percentage uncertainties, you add. You always add. You don't subtract, you don't multiply, you don't divide, you always add. So the value comes to that, and the percentage uncertainty comes to that. Then you have to convert this percentage uncertainty back to absolute uncertainty by multiplying 8.4% by 3. That gives you that. And then round this off to 1 sig fig. That gives you 0.3. And then round this value off to 1 dp, because the uncertainty is to 1 dp. So the final answer is 3.0 plus or minus 0.3. Take note, if you just write 3 plus or minus 0.3, that will be wrong, because they will have inconsistent number of dp's. Answers. The radius is expressed in terms of percentage uncertainty. So you convert the absolute to percentage. For pi, it has no uncertainty, so 0%. And then we first of all square the radius, square the value, and it becomes that. And then you multiply the percentage uncertainty by 2, and it gives you that. Then we multiply r squared by pi. That's pi there. Multiply, that's r squared here. And then you multiply pi by this number here, r squared, and it gives you that. And then you add the 2 percentage uncertainties together, and it gives you that. Then you convert the percentage uncertainty back to absolute uncertainty by multiplying 1.58% by this value here, and it gives you 7.88. Round it off to 1 sig fig, gives you 8, and that's to the nearest unit. Therefore, you round the value off to the nearest unit. The final answer is 499 plus or minus 8 centimeters squared. Part D, square root. Square root is the same as power of half. That is, you can see that square root of x can be written as x to the power half. Once you have calculated the percentage uncertainty of the particular quantity, then you just halve the percentage uncertainty. And the rest of the steps are the same as previously discussed.